In this video, we have a word problem featuring both instantaneous and average rate of change, and the role that derivatives play in computing such rates of change. Now, here's our function that represents the amount of fuel consumed by a factory. So the function f of t describes fuel using barrels as units, and is a function of t, which refers to time. In this case, it's hours since the factory has opened to start the day. So say if the factory opens at 6 a.m. and t equals 0 would correspond to 6 a.m., whereas t equals 3 would correspond to 3 hours later, 9 a.m. So we have 0.4t squared minus 0.2 t to the 0.3 power plus 20. So there are 3 questions to answer about the fuel consumption. So how much fuel has been consumed after 3 hours? What is the rate of consumption after 5 hours? So that would be an instantaneous rate of change, for which we need a derivative. And then here we have a average consumption of fuel during the first 7 hours. So that is an average rate of change, for which we do not need a derivative. So for our first question, how much fuel has been consumed after 3 hours? For that, we just need the original function. The answer would be given by f of 3. So that would be 0.4 times 3 squared, so that would be 9, minus 0.2 times 3 to the 0.3 plus 20. So for the middle term, even I can't do that without a calculator. Okay, so to work this out using your calculator, so I'll do the middle term first. So 3 raised to the 0.3 power is 1.39 times 0.2 negative, and then, well, 9 times 4 is 36, so 9 times 0.4 is 3.6. So I have plus 3.6 plus 20, and we'll round all our answers to 2 decimal places, so we get 23.32. So that is the final answer for the first question. Now, for the rate of consumption after 5 hours, so rate of consumption, that is an instantaneous rate of change. That means derivative. So we want f prime of 5. Now, to get f prime of 5, we first need f prime of t. So let's compute a derivative of this function using our various differentiation rules. So f prime of t would be, so 0.4 times the derivative of t squared, which is 2t. I'm going to have minus 0.2 derivative of t to the 0.3. Well, that's 0.3 t to the 0.3 minus 1, which is minus 0.7. And then you take a derivative of 20, but that's a constant function, and the derivative of that is 0. So now we just need to simplify this, and we get 0.8t, and then 0.2 times 0.3 is 0.06, so minus 0.06 t to the minus 0.7. So this is what we use to figure out the rate of consumption after 5 hours. So I substitute t equals 5 in here. So I have 0.8 times 5 minus 0.06, 5 to the minus 0.7. Now 5 to the minus 0.7 is the same as 1 over 5 to the 0.7. So work out a calculator. So 5 raised to the 0.7 power, and then I take 1 over that, and multiply that by 0.06, and negate that. Now, 5 times 8 is 40, so 5 times 0.8 is 4. So I'm going to add 4 to this, and rounding to 2 decimal places, I get 3.98. So that is, now fill in the units here. I should have done it earlier. So for our first question, how much fuel is consumed after 3 hours? That's 23.32 barrels. For rated consumption for 5 hours, that would be barrels per hour. Because we're taking a derivative with respect to T. So for our units, we divide by the unit of T, which is hours. Okay, finally, the average consumption during the first 7 hours. So that would be F of 7 minus F of 0 divided by 7 minus 0. So we're looking at the average rate of change. So we need F of 7, so that would be 0.4 times 7 squared, which is 49, minus 0.2, 7 to the 0.3, and then we have plus 20. Now F of 0, we plug in T equals 0 there, the only thing we're going to get is 20. So those are going to cancel out. And then all of that is divided by 7. Okay. So now working this out on calculator. So I have 7 raised to the 0.3 times 0.2 negated, and then plus 49 times 4 is the same as 49 double twice, so 98, then 196, but it's 0.4, so that would be plus 19.6. Okay, and then I divide that by 7. So the 2 decimal places, I get 2.75. That's my answer. And that also is barrels per hour, because what we have up top, function values are in barrels, and then down below, in the denominator, we have time values that are in hours. So we have barrels per hour. So what we can see from this is that at 5 hours, fuel is being consumed at a faster rate at that time than over the whole span of time from opening of a factory to 7 hours later. So 5 hours is perhaps close to a peak time. Later on in the course, we would be able to figure out at what time was the fuel rate of consumption of a maximum.